Alrighty, I think we are live in all locations. Hello, 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 and welcome to the very first episode of Ask Databricks. So we are super excited. This is our first time trying this, first time trying it out. The whole point of this show is to give you the ability to ask questions directly. I'm going to mute myself, talking at myself. There we go, lessons learned. And yeah, the whole idea is we're going to have guests each week talking about a different topic to do with Databricks. You guys come along and ask all of your questions. And I cannot stress how important that is. We need your questions. So anything you want to know, anything about Delta live tables is the plan for today. So yeah, that's what we're going to do. So my name is Simon Whiteley. Hello. I talk a lot on YouTube about Spark and all that kind of stuff. I say hello Spark fans a lot. And yeah, I run a company called Advancing Analytics in the UK. So if you're doing anything to do with Delta and Databricks, give us a shout. But it's not about me. Today, we are very lucky to be joined by Michael Armbrust. I'm going to bring him onto the show. Hello, Michael.
Hi, Simon.
Thanks for joining us in our very first experimental show as we see how it goes. How's it going?
Great. I'm really excited to be here.
Awesome. So, I think the whole plan. I mean, I've got a list of questions. I'm really happy to see there's a giant pile of questions coming in already. But I think it's quite important when you're doing this and you're learning about the tools people have built and kind of all the great tech that's coming out to kind of understand a bit about the people behind it. So you want to give us an introduction, tell us a bit about yourself, your history, and how did you get into tech?
Yeah, absolutely. So, I've always liked computers, but I did my PhD at UC Berkeley, and I was actually in the same lab as the people who built Spark, although I wasn't working on Spark at the time. I was working on kind of more real-time OLTP style database things. And then after grad school, I thought I wanted to be a professor. So I actually went to Google and I did a postdoc there for a couple of years. And partway through my postdoc, I just happened to go on this 30th birthday trip with Andy Konwinski, one of the founders of Databricks. And Ali Ghodsi, the current founder, was there. And he spent literally the entire weekend trying to recruit me to Databricks. And I remember we were actually like driving around the island in Hawaii with my now husband and his now wife. And they were like, you guys need to stop talking about this.
But like why are the doors locked kind of moment going?
Exactly. But it was a very compelling pitch. So I actually flew back to San Francisco, went directly to Google from the airport and quit my job and started at Databricks.
I mean, it's been an awesome story. So you've worked in some of the big, like some of the features that people are working with in Delta, Databricks, Delta, all those things. What are the big ticket items that people should know you for?
Yeah, so when I first started, I worked on Spark SQL. So I wrote the Catalyst Query Optimizer and the first version of the exection engine, which I think
just a small thing, Yeah. Fine.
I think at this point it's been completely rewritten, especially the execution engine. And then after that, I created the team that did structured streaming. So basically taking Spark SQL and rather than answering a question once, answering it incrementally as new data arrives. And so we worked on that for a couple of years. And then what we realized everybody was doing with structured streaming was they were using it to do ETL. They were reading from Kafka, Kinesis, files, and then they were writing out Parquet files on S3. And the good news was we were really good at doing that at scale. The bad news was having 10 million Parquet files on S3 is a pretty awful situation to be in. We had a couple of customers where even just loading the table would take almost an hour. And so we realized something had to change. And so we created Delta, which is basically a transactional storage layer on top of these Parquet files that allows you to efficiently filter them and do transactional ACID operations on top of them. And after Delta, once you have transactions, there's all kinds of cool things you can do. So we built streaming sources and syncs. We built update, delete, and merge. We built statistics and compaction. But then kind of what I realized was, these tools are great. If you're an expert in Scala, if you're an expert in Spark, you can build some really cool data pipelines with them. But that's a tiny fraction of the world. And that brings us to Delta Live Tables. The vision of Delta Live Tables was to take all of these different technologies that we built and basically make them accessible to someone who only knew, a few lines of SQL. And so basically the idea here is what I call declarative ETL. Rather than writing a program that moves data and understands partitions and figures out what has changed and all of those things, you just say these tables should exist and you leave it up to us to figure out how to make that true and how to do it most efficiently.
Hey, it makes a lot of sense.
Yeah.
And it's pretty much what everyone's been trying to build. You know, there became a tipping point when, like, the industry people were building one-off pipelines and just managing tons of scripts, and then everyone went, well, this is terrible, I'm going to build my own framework. So there's a million things out there of kind of like homegrown cottage industry. I'm going to take some metadata and I'm going to do it because it's just a smart way to do things.
Absolutely. So, there's like a lot of patterns, and you don't want to just do that same heavy lifting over and over again. But I think the exciting thing about doing it at a company like Databricks is, you know, rather than your 3-person ETL team building and managing their own framework, we have 50 engineers who are experts in Spark building the framework, hopefully once and for all.
Very good. I mean, that is a good ambition. And yeah, it's very, very cool. All right, should we start fielding some questions? I'm starting to get inundated with questions already, which is good news.
Yeah, let's get started.
Let's see what we have. I've got a bunch of questions that are, you know, kind of just some nice scene-setting questions, but I think we can just dive into some nerdy questions that we're getting from the stack, right?
Sounds great.
Okay, cool. So what are the ones we got? Can you use percentage run in a DLT pipeline? If not, how do you extend your code base for Delta Live Data?
Yeah, that's a great question. So first of all, what is %run for people who don't know? %run is this kind of weird magic command that we created in the very early days of Databricks. Basically what it does is it takes another notebook and just runs those cells inside of that cell within the notebook. It's had many kind of gross and hacky implementations over the years. And when we created DLT, one of the things we wanted to make sure that we would support was, you know, I'm sure this question is going to come up. We want to eventually make it possible to run DLT locally and outside of Databricks. And so we tried to avoid as many weird Databricks things as possible and tried to be more standard SQL and standard Python. So we do not support %run, but we absolutely support modularizing your code and reusing code, doing all of these things. And there's a couple of different tools you can do for it. First of all, a pipeline. So a pipeline is the object that you create in DLT. It's a collection of streaming tables and materialized views. And a pipeline is defined by a whole bunch of notebooks or files. And so a pipeline can have multiple notebooks. So already you can just spread your code out across all of those notebooks. You don't need %run. And you can just include all of those notebooks in the pipeline. And the way it works is when we start up, we read all of those notebooks, find all of the tables, discover the dependencies between them, and then actually run it. Now, you might say, okay, that's great, but what if I actually want to use code from that other notebook in this notebook? Like I want to create a function or a module that I'm going to reuse across multiple notebooks. And the answer is the standard Python way. Create a Python module, use Python import. That should all work perfectly inside of DLT.
And even that's had a big switch recently. So if in the Databricks side of things, you know, so people have gone through that level of maturity where you used to just write a notebook and use %run because it's the easy way of doing things. And then we got a little bit better. We got a little bit more software engineering, and we wrote a Python wheel, and we attached the Python wheel onto the library, and you can do that in DLT.
Yep, that's right. You can attach wheels, or you can even just use the repos or workspace file interface to import those directly without having to package it up as a wheel.
Exactly,
So
and that's now the modern way of doing things, right? In that you point at the repo, don't bother actually putting it anywhere. You can have multiple people using the same cluster on different feature branches, and it's okay.
That's exactly right. So one of the kind of key ideas of DLT is I want to bring the rigor of software engineering to the kind of data analytics community. And so you'll see this in many of our design decisions. We're trying to do it the like proper software engineering way.
It's been a journey, you know. Data folk, we've been behind like software engineering, probably about 5-10 years behind. I still occasionally meet people and like, what's Agile? How does Agile work? And it's like, oh, okay, cool. We're going to have that conversation. But we're getting better as an industry. We're getting there.
Yeah, absolutely.
All righty. So more questions. So is change data feed a separate feature from CDC? Or does change data feed get integrated into a CDC pipeline?
Yeah, that's a great question. Let me break this down. So first of all, CDC is change data capture. It's this like generic problem that is, you know, as old as time, where I have one system and I want to capture the changes from that system and replicate them into another system. And there's a bunch of different facets to this that are supported inside of Databricks. So first of all, if you just have a Delta table, Delta tables have change feeds. And it's not only Delta tables that have change feeds, your MySQL database, your Postgres database, pretty much any relational database that you have will have a change feed. If you want to use the change feed, all you do is you set this option to enable the change feed on the Delta table. And then you can either use kind of a table valued function where you say, give me the changes between these two versions. Or more commonly, what people will do is they'll just stream the changes from that table. And now you basically get the updates, deletes, and inserts, as a stream from that table. So that's like the kind of source side of change data capture. Now let's talk about what you do with those changes. So before DLT, you'd have to do something pretty complicated. You'd have to create a stream, you'd have to do for each batch, and then you'd have to merge those changes into a table. And that sounds pretty easy, but there's a bunch of complexity. And the biggest complexity is ordering. Most streaming systems don't guarantee that the data is going to arrive in a perfect order, especially if you're doing something like uploading files to S3, which is a super common case. And so what you end up doing is you actually have to reorder the data on the fly as you merge it. Make sure you're not updating a more recent value with an older value. And this requires big, complex SQL queries that do window functions. You actually, if you're in the kind of most complicated case, you have to store a vector clock inside of the database of when each column was updated in time so that you know which column should be updated. And DLT said, no, that's way too difficult. Let's make this a lot simpler. And we created this new SQL command called apply changes into. The idea of apply changes into is you can take a change feed and apply it to a Delta table. And we take care of schema evolution, ordering, all of those complexities are kind of handled for you. You tell us what the primary key is. You tell us what column talks about ordering. And that can be any column that can be ordered. It can be a timestamp. It can be a log sequence number. It can be the upload time of the file, whatever makes sense for your particular application. And then we take care of all of the details under the covers. One important thing to realize here, though, is this requires us to do extra bookkeeping. So that apply changes into table is going to have these extra columns that tell us when that row was updated in time, so that when another row comes, you know whether or not it should override those values. And so you'll notice that when you query that table directly, you see these extra columns. You'll also see tombstones. You'll see deleted data because we need to remember that a row was deleted in order to prevent it from being reordered as a zombie. Now, you don't really need to understand all of these things. All you need to know is tell us what the primary key is, tell us what the ordering is, and read the table through Unity Catalog, and all of those details will be taken care of for you.
Right, but for me, there's very smart detail in terms of getting people on board, right? Because you're taking something that's essentially a merge statement, but gives you some flexibility to say sometimes it's not a merge, sometimes it is a merge, whatever.
Yeah.
But if you're trying to get SQL people on board, and you're like, we've changed the syntax of the merge statement, and everyone goes, oh, really? And then you go, but we've allowed you to do slowly changing dimension just at a click of a button. Suddenly, everyone's very happy. You've got the SQL right. people on board now.
Yeah, that's absolutely right. And that's a good point that I should also highlight. Apply changes into can do more than just SCD type 1, which is, updating in place. If you're in some kind of regulated industry, or even if you just want to be able to reproduce results from the past, you can just add another clause to it, SCD2, and then we will keep a history of how each row has changed over time. And let me tell you, I have never seen a correct implementation of streaming SCD2 outside of DLT. I actually made them delete all of the examples from our documentation because they were all wrong. It is a super hard problem. It is very difficult to get correct.
And often goes very slow if you try and do it manually, and you end up with some very nasty things. We've seen some things.
Yeah, I can imagine. And then one other thing I should talk about, as long as we're talking about change feeds, is I want to distinguish the difference between a change feed and a snapshot, because there's another really cool feature coming out called apply changes from snapshot that lets you do kind of even different things. So a change feed is a list of this row was inserted, this row was deleted, but sometimes you don't have the administrator permissions on your database to enable that kind of feed. Sometimes you can only get the entire data set at once, and you still want to understand how it's changing over time. This is when you would use apply changes from snapshot. Instead of taking a change feed, it takes the entire table in and it compares the current version with this new snapshot you gave it, and it detects the differences either in SCD1 or in SCD2 mode.
That's very cool.
Yeah, I'm pretty excited about it. I think we now have a pretty comprehensive change data capture story.
Okay, we got a different track. I'm kind of dipping over to LinkedIn for a second. I'm not able to convince my non-technical manager about DLT. He thinks it's a bit new. He thinks it's a bit emerging. How do you deal with that? How do you sell it to people who are a bit skeptical because it's new?
I mean, DLT is pretty new, and it's kind of a different way of thinking about things. But we're not the only project kind of in this space. So, if you want to kind of appeal to authority, other systems that are doing similar kind of trying to bring the rigor of software engineering to data pipelines are things like DBT. So I think you can talk about those kinds of things. But really, I think the best thing to do is look at some of the case studies that we published online. I think the most compelling things to managers is when you start talking about TCO, and we have some pretty kind of exciting examples there. So we have customers where they have said that, they wrote their data pipeline without DLT, and it took them 6 months and, many developers to get it working performantly and working correctly. And then they wrote the same pipeline in DLT in days to weeks. And so I think when you start thinking about those kinds of productivity improvements, when you can focus on getting value from your data rather than all of this undifferentiated heavy lifting that every data pipeline needs to do, retries and parallelism and dependency management, all of that kind of stuff, I think that can be very compelling. And if that's not enough, it's not only the development, it's actually also the operational costs of running the pipeline. So DLT pipelines have better parallelism. There's a pretty cool blog where we show that we ran TPC DI on, I think it was 1 trillion records for $1. And that's really just because we manage the cluster much more efficiently. We have better auto scaling, which works with diurnal patterns and streaming. So we will scale the cluster up and down as your usage changes. We've seen up to 30% savings from that. And then finally, talk about how much bad data costs your organization. If you use things like expectations, you can catch bad data before it starts affecting downstream things. And it's almost difficult to quantify how much value that can provide.
I'm a massive fan of expectations. It's just a good thing. I do a question along those lines. So lots of times we've spoken to clients. This is a cheeky question from me I'm throwing in. Is there an upper limit in terms of number of tables you'd see? Because that kind of scenario where we have clients that have got existing legacy system with 1,000 tables in a SQL server, and they're like, we want to turn all of this into a lakehouse, which is great, and you can manually scrape all that data and getting it through. Is there kind of a limit to how much you try and fit into a single data DLT pipeline, and how do you start breaking up? How do you think about componentizing your componentized pipeline?
Yeah, that's a great question. And I'm going to give you the answer today and also where we're heading. So today, absolutely. The kind of rule today is it's one DLT pipeline, one cluster. And so you do start to hit upper limits on the driver of that cluster. So, just quick Spark lesson, there's kind of two components. There's the driver, which is what does all the query planning and scheduling and distribution of work to the cluster. And then there's the executors, which actually do the data processing in parallel on little chunks of the data. And so typically where you'll start to see problems with DLT pipelines that have hundreds or thousands of tables is on the driver. Now, this is super workload dependent. And so unfortunately, I can't say 50 tables is okay or 100 tables is okay. We do have customers that have pipelines with hundreds of tables. But, basically here's how I would think about it. It has to do with the number of tables, the size of the schema in those tables, the size of the metadata for the tables. And then really the other biggest factor is the size of the driver. So what I usually recommend is tens to hundreds of tables per pipeline. If you start to run into problems, use a larger driver instance with more memory. Past that, you should start partitioning into multiple pipelines. As we move towards serverless, though, I want to start breaking these abstractions. So we have a bunch of kind of ongoing research work into what it would take to kind of go in both directions. I would love to say if you've got 20 tiny pipelines that each have one table, let's pack them into a single cluster. Similarly, if you have one giant pipeline that has 10,000 tables, let's run it on 10 different clusters. That's absolutely something that we are investigating, but it's also a very hard problem. So for today, partition your pipelines, partition your tables into multiple pipelines.
And there's a question that's related to that, which is now we can use Unity Catalog with DLT, which is great. So that's Unity Catalog, future of Databricks, and all loads of features coming in there. When you couldn't use them together, that's a big limitation. Now you can, which is great. But when people are trying to load, 50 or so different tables, they struggle not being able to split across different catalogs and schemas. So how do people think about that now, and kind of how should they think about it in the future?
Yeah, that's a great question. So today we are in private preview with a feature called custom schemas. And actually, I think that's a bad name because I want to explain exactly what this feature does. I think it should be called isolated schemas. And I started talking with our product manager about this yesterday because isolated schemas is specifically for doing CI/CD. When you publish to an isolated schema, it actually kind of does the string munging that many people do in their data pipelines automatically. So if I have a bronze database and I have the development version of it, it will publish to bronze_dev. It concatenates those two things together to guarantee that you are always, like if you have two different users who are working on the same code base, they will be publishing to these isolated schemas. We will expand that to work with catalogs as well. But we're also going to support the much simpler version for people who aren't quite so sophisticated that they have multiple developers working in isolation today. And we will support just direct publishing to multiple schemas and catalogs. That's actually a pretty high item on our roadmap, but that is a limitation today. You cannot do that yet. You would have to break those into separate pipelines today.
Cool. And there's one kind of following up that, more kind of breaking things up and thinking about it. Medallion architecture. So if you're building out bronze, silver, gold, what are your best practices in terms of thinking about that, and especially plugging in some of the new things, so materialized views and streaming tables, and how do you think about those layers, and how should people kind of construct it using DLT?
Yeah, interesting question. So first of all, let me kind of clarify. Bronze, silver, and gold was this kind of cool pattern that I saw when I was going, I kind of did this Delta world tour where I went around and gave the Delta talk all over the world. I guess it was 5 or 6 years ago now. And I think it's a super cool idea, but it's totally made up. It's not a feature. There's no strict rules about what bronze, silver, and gold are. You do not have to store them in different storage buckets. You can map it to whatever your company means. There are no hard rules here. But I think it's a very useful vocabulary for talking about data quality, for thinking about how we incrementally improve it, and also communicating with your downstream users which tables they should be using for which types of tasks. And when they should be kind of like, oh, this data is dirty, I should not be making assumptions about the results unless I understand how it's being produced. So that said, how should you be mapping this into DLT? And how do you map it specifically into streaming tables and materialized views? So first of all, what's the difference between a streaming table and a materialized view? How do you think about it? These are both engines for doing incremental computation, but they have different rules and as a result kind of work in different cases. So streaming is about performance. It makes this guarantee that the input data will be read only once, no matter what. Except for failures where we have to retry. But the result will be as though that data was read only once. This is great for throughput. This is great for efficiency, but it has some kind of interesting characteristics that you'll need to think about. If you change your query, the stream does not go back in time and recompute all the data that was already read. If you're joining with a static dimension table, that dimension table will update each microbatch, but we do not go back in time and update rows that were joined with a stale version of that dimension table. Again, this is great for performance. If you have a petabyte table, and we actually do have people who use streaming, ingesting petabytes in a single day, you could not afford to go back in time and recompute. You would never want the system to do that. Materialized views are kind of the opposite end of the spectrum. They prioritize correctness. We will do whatever we need to do to get you the correct answer. If we can do it incrementally, great. If we don't know how to do it incrementally, or it's not possible to do it incrementally, we will compute the whole thing from scratch. This is super easy to reason about, but if you have a petabyte table, it might not be the right abstraction for you. So here's how I usually think about it. For ingestion, always use streaming. Ingestion is kind of always an append-only process. Often want to clean that data up anyway, so you don't want to go back in time and read it. Like keeping raw data in text files is a great way to violate GDPR. So absolutely use streaming for ingestion. Then oftentimes you should be using materialized views for transformation. And this works best on DLT serverless, where this kind of cool engine called Enzyme will work to incrementalize those queries. And so Enzyme is the engine that takes a materialized view and rather than recomputing it from scratch, attempts to update a previous answer, with only the data that is changed. Enzyme is a rapidly evolving technology, And so it handles certain shapes of queries, but not all queries. If you have two tables partitioned by date, Enzyme is great at that. It will only update the dates that change. If you have aggregations where you do a group by and then an associative aggregation, like sum, count, average, Enzyme is great at that. We are adding support for select, project, union, and inner joins in the next couple of weeks. And that I think that'll be pretty good. And in the long term, we will support window functions and outer joins and all the different things that 60 years of database literature have figured out how to incrementalize. But I'll be perfectly candid, we don't do all of that today.
So that's kind of a reason for people to be thinking about using DLT now, because that's coming down the line and they can start seeing that, and then they'll just start seeing things get a bit like when Photon was introduced, right? It could do a load of stuff, but not everything had been vectorized, and then slowly you see more and more of the job happen on the Photon side. Kind of a similar idea. Build it now and it'll just get better and better and better.
That's exactly right. With no changes to your code, as Enzyme improves, your pipelines will get faster and faster. And I'll say it happened with my data pipeline. I of course use DLT just to analyze how DLT is being used. And I think my pipeline went from taking over an hour on a huge cluster, like hundreds of executors with 32 cores each or something crazy like that, and it went down to like 15 minutes with Enzyme. So it can be a pretty crazy change. But yeah, I think that's exactly right. So just to summarize, always use streaming for ingestion. Use streaming if you have massive scale and are willing to deal with the complexity for transformations. Otherwise, use materialized views and make sure you understand that you should be using serverless and what kinds of things Enzyme is optimizing today, and just make sure that's meeting your SLA and know that it will get better and better over time. Very
cool. All right. I'm going to bundle a couple of questions together. So development best practices. A lot of people asking about how can you test a DLT pipeline? What's the best way to work with that? People saying, can you work locally with them and how that works? So kind of just generally, what's the best way to go about building it and making sure it's good, and essentially adding coding discipline to your pipeline?
Yeah, great question. So first of all, like the first kind of step of proper software engineering lifecycle is always use version control. So you should be using Databricks repos, and you should be putting all of your code in there, and you should be making pull requests and working with your coworkers to code review and make sure that everybody understands what's happening and there aren't mistakes in it and that kind of stuff. Now, how do you do that? So you can do that inside of the workspace using Databricks repos, or you can do that locally. And when you're developing locally, there's a pretty cool tool that we just announced at Spark Summit, and I believe just went into public preview, called Databricks Asset Bundles. And this is basically, you can think of it as like a layer on top of Terraform. And what it's doing is it's bringing some rigor to the actual step of deploying this to your Databricks workspace. So you write down, this pipeline should exist. You run this command, and it will use Databricks REST APIs to upload the latest version of your code, and then make sure that that job, that notebook, that DLT pipeline, any of the assets that exist inside of Databricks exist and have the correct configuration. This is great because now you can develop locally, and it's also great because it has this built-in idea of environments. So you can say, I have this kind of base configuration that all of the pipelines use, but when I'm in development, I want to make some tweaks to it. I don't want to read all of the data every time. I just want to read yesterday's data because I want my development loop to be really fast. And you can publish to a different target. Target is that thing we talked about before that kind of isolates your different pipelines so they're publishing to different locations inside of Unity Catalog. So I'll publish to a target called Michael_dev. And that way, if Simon is working on his version, publishing to the Simon schema, it'll be separate and isolated. And then there's a production version that runs over all of the data and uses a larger cluster and uses the right policy and service principal and all of those kinds of things. So absolutely use version control, absolutely use dabs. And then the other thing I'll say is you want to make sure you break up the logic of your pipeline into two classes. You want to have sources and transformations. The sources are the inputs that you're reading from somewhere else. And you want to put these in separate files so that you can override them, as I was talking about before. You want to have like your production source, which reads the whole data set, and your development source, which reads a partial data set to be back. Transformations, on the other hand, are the same. No matter where you're running, they just read from whatever the sources are and produce the correct answer, either a subset or the entire data set. And the nice thing is DLT's dependency management mechanism will just automatically link all these things up.
I mean, and that I've not played with it yet. I am so excited about asset bundles just because the number of times I've had to help people essentially build a load of custom scripts to say, have this job on that workspace, this job on that workspace, and keep them in sync has been a manual thing for a long time. So asset bundles just for that is huge. And managing DLT, it's going to be great.
Yeah, it's really, so I'm actually in the process of converting my pipelines over to dabs, as we call them internally. And it's great because, you know, when a new person used to onboard, I would have to sit down with them and teach them how to check out the repo and how to create a pipeline and which notebooks to include. None of that stuff was automated. And now it's as easy as them running git checkout and running deploy. And they have their own isolated copy that they can develop in. It's pretty cool.
That's awesome. I'm getting messages saying I'm not allowed to dab. I won't. It's fine.
There was one part of that question I didn't answer, which is, you know, how do you test? Like, what's that testing process actually look like? There's no way to run DLT locally yet. But what I generally recommend you do, and I think this is actually a best practice, is you really want to test your stuff in the right environment. You want to test it on Databricks runtime, in the cloud, reading from Unity catalog. You really want to be 100% sure that it's going to run when you switch it over to production. And so what I recommend doing is you create another environment in your DAB called test. And it can read the whole data set. It can read a partial data set, whatever makes sense for your application. But there are some example scripts that will actually connect that to GitHub Actions and other kind of automation systems. And so you can set up a complete pipeline where when someone opens a pull request, it will run the test automatically in the correct environment, you know, on a small cluster, on a small data set, so it doesn't cost a bunch of money. I think that's a pretty good pattern for doing testing.
I'm just gonna ping to some of our guys in the chat. There's actually a blog that you guys put out, which is applying CI/CD practices to Delta live tables, which have got really good examples for doing things like, here's what you do your unit testing. Here's how you think about actually plugging these things in. So I've pinged the link and hopefully we'll share that in the various chats because there's just loads of stuff in there.
Awesome.
Right, cool. Yeah, we still got a little bit of time. Look, what have we got? One, which is fairly straightforward answer. What's the performance difference between using SQL and Python in DLT?
Yeah, great question. There shouldn't be a difference. So if you think about how Spark SQL works, basically, you know, if you go back to like my first Catalyst talk from 10 years ago, there's this kind of front end, which is, you know, SQL, data frames, Scala, Python, whatever. And all this layer is doing is it's constructing what we call a logical query plan. So it's creating this tree of operators that are, you know, scan this Parquet file, do this filter, project these columns out, do this join. And after the logical query plan, it all executes on Databricks runtime and Photon exactly the same way. So, you know, if you write data frame code and SQL, they really end up executing in a pretty equivalent way. Let me give you a couple of kind of things to consider, though. So if you use UDFs in Python, there is some performance overhead to that. So like, let's say, for example, if you do A plus B in an expression versus doing a UDF that did A plus B, the expression is going to be dramatically faster because it's actually going to run in Photon in a vectorized way without actually having to move the data from anywhere to anywhere. And so if you can express your stuff in expressions, you should always use expressions. But this applies to both Python and SQL. You can write these expressions in both cases. And there's some things you just can't do with expressions. And so you should absolutely use UDFs in that case. And if you use Pandas UDFs, where we actually send you a whole vector of rows at a time, that will decrease some of these costs of context switching back and forth between your code and the engine code.
I think I'm right in saying if people are facing that choice and they have to go UDFs, even though they shouldn't have to. But if they have to go down the UDF one, SQL UDFs, which you can do these days, are actually going to be more efficient, right? Because they are going to run on their native engine.
That's exactly right. Yeah, when I think SQL UDF, I think exactly expressions. What you're doing is you're just creating a macro for expressions, and so you're never leaving that vectorized Photon execution system. And so you're absolutely right. It'll be much faster if you can do it that way.
So avoid things.
Yeah, so really, that's right. So when it comes to deciding between SQL and Python, in general, you should do what you're most comfortable with. The only case where I would recommend Python is when you start getting into metaprogramming. So metaprogramming is a kind of cool thing you can do with DLT, where instead of writing out, I want these 10 tables, you have a for loop that creates 10 similarly structured tables with some logic. That's something that is restricted to Python.
Yeah. And again, like early experimentation with that last year, doing that and building a little framework that says, hey, I've got these 50 tables that I need to load, and I need to put them all into a raw layer, and I need to put them all into a cleaned layer, a bronze layer and a silver layer. That is so automatable. So a lot of the patterns that we see, we have one notebook, which is just land the table and then clean the table. And then you have all your different business logic as separate notebooks, but you can not having to have a single notebook for every single different table you're loading. Suddenly you're starting to see benefits of it.
Yeah.
Is that something you'd ever build in?
What's that?
Is that something you'd ever want to build into DLT and actually have? Because if people are building a framework on top of your framework, should that be something the framework does, or is that?
Well, yeah, that's a great question. I mean, I think that it's very likely that there's a lot of business-specific logic in this framework. And so I don't see a problem with it. I like it. I think we will always support metaprogramming. I think it's pretty powerful. In addition to just keeping your code simpler, something I've seen people do is actually use it to enable the less technical people in your organization. So I've seen people where, basically there's a spreadsheet that says which tables should be ingested. And some business analyst who doesn't even know SQL, who only knows how to use drag and drop UIs, can add a line to that spreadsheet. And now the data pipeline start adding this new table kind of automatically. So that's pretty cool. But I think you're also right that there are some patterns that are general. All businesses have to do them. Ingest data from Salesforce, for example, things like that. Read a bunch of files from S3 and put them into a table, whatever that might be. I don't want to say anything too specific, but I think it's absolutely likely that there will be layers on top of DLT inside of Databricks that automate some of these ingestion and transformation tasks.
That's very cool. And I've got a follow-up question on there. So one of the questions in the chat is, any plans for a graphical user interface for developing? Because it's an interesting thing with Databricks. Whenever you guys say low code, what you actually mean is writing some code. When everyone else says low code, they mean draggy, droppy, move some boxes around kind of thing. Is there a plan to kind of try and attract that kind of user who is going to be the drag and drop and build some table abstractions?
So let me first say, we'll build, we're customer obsessed. We'll build what the users ask for. So if this is something you need, talk to your Databricks representative, open a feature request. I will consider building anything. But then I will tell you my opinion, which is those things make great demos and they break down in real usage. I think the kind of core problem here is it's very difficult to do version control on top of things that are created in these draggy, clicky interfaces. And so as soon as you start having a team of people own this data pipeline, that abstraction really starts to break down. And so my favorite is like very low code, SQL only. You don't need to know Python, but there's just this precision in SQL and this flexibility in SQL that is very difficult to get in a clicky, draggy interface. The exception to this, though, I do think is ingestion. I think ingestion tasks are relatively simple and straightforward. And I think it's very likely there will be kind of GUI only tools that do ingestion with DLT at some point.
Okay, very cool. Got another question just come in. Is it possible to run a table with all downstream and upstream dependencies? So just kind of doing partial runs of pipelines, and how does that work for like the slightly more complex orchestration?
Yeah, so we have this API called refresh selected, which allows you to say, do these tables. I don't think it supports like cascade where upstream or downstream, but that's a great feature request. That would be pretty easy for us to implement. So again, talk to your Databricks representative. I will make a mental note that someone asked for this because I think, yeah, that's absolutely something we could add.
I mean, certainly if you pick a table to refresh that's downstream, it is kind of magic in the, well, we'll get the data to that point and then carry on, which is cool, even without materializing in media things, which is cool.
Yeah, that's right. And there's another kind of related public preview feature or private preview feature that's coming out in the near term, which is table triggers, where you can say in Databricks workflows, run this job, run this DLT pipeline, run this whatever when this table is updated. So, I think we'll add this API for just kind of doing it one-off ad hoc, but there's also a way to there will be a way to kind of productize this. So really anytime one of your inputs changes, your data pipeline can automatically run, which I think is pretty cool.
Cool. I've got couple more ones around. So DLT and DBT. So in what scenarios would you consider using one or the other, and kind of how do they work together?
So I love DBT. I think it was a pretty cool project. I think we started around a similar time with very similar goals, and even some of the features inside of DLT are inspired by DBT. And the coolest thing is you don't have to pick which one to use. Now that you can create streaming tables and materialized views inside of DB SQL, we have a kind of new beta version of the Databricks adapter where one of the materialization types inside of DBT can be a streaming table or materialized view. And I think this allows you to overcome kind of one of the key weaknesses of DBT. So again, I love DBT, but at its core, what DBT is doing is it's string munching, right? It's like building SQL queries, but it doesn't have a parser and an analyzer. It can't understand what those queries are really doing. And this is where kind of DLT being built into the Catalyst query optimizer is special. We can look at that query, we can break it up, we can figure out how to incrementalize it over time. We can do things like enzyme. And so when you start using these two on top of each other, I think that's when you get the best of both worlds. If you've got tons of DBT pipelines, you've got lots of analysts who are familiar with it, great, you should absolutely use that against Databricks, but have them create materialized views and streaming tables so you can read from Kafka, Kinesis, Autoloader, so you can use these cool technologies like expectations or enzyme to incrementalize the updates.
All right, very, very cool. Okay, I think that is the list of questions I'd managed to pull out. I think there's a ton more questions in the chat. What I'm going to do is, we've got so many questions. What I'm going to do is pull it out. We'll probably make it just a blog of a load of that Q&A, because if people are asking questions here, it's probably useful questions for them to do. So we'll follow up afterwards, and we'll drop a link around so people can go and just see all of these various different questions. But yeah, it's kind of a final couple of minutes. What should people do? What should people do next? What are you excited that's coming up in the future of DLT?
Yeah, that's a great question. I mean, so the thing I'm most excited about is probably DLT serverless, because like I said, I think there's just, once we start fully managing the servers, there's a lot of cool things we can do. Let me talk about what is there today and what we're working on for the future. So today, when you flip, so it's just a checkbox that you add. It's a private preview. Talk to your account representative to get added. Your pipeline needs to be using Unity Catalog, because that's how we do security inside of serverless. But if you've got a Unity Catalog pipeline, you should be able to turn it on and turn it off easily. There's a bunch of really cool features inside of serverless. First of all, you don't have to think about quotas. You don't have to think about machines. You don't have to think about instance types. All that stuff is taken care of for you. That's kind of the like basics of serverless. But also you get enzyme. So your materialized views will incrementalize. You get microbatch pipelining. We do dramatically better scheduling of your streaming queries. And this can mean up to 2x efficiency gains in some cases. Basically, rather than running microbatches back to back, we now start the next microbatch before the previous one is finished. And so if you used to watch the utilization of your streaming pipelines, it would go up to 100 and then would go down to 0 and up to 100. This keeps you utilizing that cluster at 100% all the time, which is just dramatically more efficient. We have some pretty cool admission control tricks. So if you're tired of setting max files per trigger in Autoloader to get the best performance, serverless automatically picks those things. And then, like I said, kind of in the future, the things we're working on is really breaking down the cluster abstraction completely. I don't want you to have to think about clusters and pipelines and how big they should be. You should really just only think about your business problem, team boundaries, things like that is the right way to segment your data pipelines. And we should figure out how many clusters, how many machines, how many executors, how much memory core, all of those kinds of things should be taken care of automatically. That's obviously a very hard problem, but we have some pretty cool research going on right now that makes me cautiously optimistic that it's a problem we'll be able to solve.
All right, very cool. Well, there's a lot coming up then. Obviously, streaming isn't available in every region, but there's still a huge amount that people can do with DLT before streaming comes along, and then hopefully they'll start seeing streaming in their own regions. I've got a cheeky final question just to make sure things are clear. Someone's saying, sounds like DLT is only for streaming use cases. What if I want to do batch? Let me just clarify this.
Yeah, absolutely. So streaming is great. I love streaming, but there's kind of two clarifications I would like to make here. First of all, when some people think about streaming, they think only about continuous streaming. So it's like low latency and it's expensive. You have an always on cluster sitting there processing data all the time. Structured streaming kind of broke this rule. It's always been able to run either in continuous mode, where it's just processing all of the data all the time, or in triggered mode, where once a day, once a week, once an hour, it wakes up and it processes what data is available. So really, when you think about streaming, you shouldn't be thinking about high cost, low latency, although that's a knob you can turn. I think of it more as a trade-off between cost and latency, and you can move back and forth on that gradient wherever you want to be. But really, you should just think about the efficiency of processing each record only once. Now, another thing you might be thinking about when you say streaming versus batch is this process anything exactly once or give me the correct answer. This is where streaming tables and materialized views come into play. Materialized views are much more like batch processing. You will get the correct answer as though you had fully overwritten that table, even if we're being more clever and not fully overwriting that table. So it's as easy to think about as batch with possibly better performance.
Makes a lot of sense. I know. I'm still have a warm glow even so long after Trigger Available Now first came out, because it just made my life so much better than just Trigger once.
It's a pretty cool feature. I like it a lot. And that's a great example of the kinds of things you don't have to think about with DLT. We switched users from Trigger Once to Trigger Available Now without anybody even knowing that was happening.
Very cool. Just let someone else do it for you is the message.
That's right. Yeah. Let our team of 50 Spark experts manage your data pipelines for you.
All right, very cool. So that is all we've got time for. So I know there's still a bunch of questions in the chat, but as I said, we'll pull those out. There's a lot of people in the chat answering questions. We'll make a giant pile of all the questions people have asked and do a Q&A. But yeah, Michael, thanks for joining us in our very first session.
Yeah, thank you so much for having me. This was great.
Yeah, it's been a blast. All right, I'm gonna kick you off the stream. Alrighty, so that brings us to the end. So thanks everyone for joining us today. Couple of things I just want to pull up quickly. Let's see if I can actually share my screen here. I can. Okay, so I'm going to bring in a quick window about what's coming up. There we go. So next session that we've got. So we've got Roland coming to join us about workflows. So we've seen DLT, Delta Live tables, actually how you're processing the data, but how do you orchestrate things? How do you actually manage when things are being run? How do you do a bunch of different tasks, kicking off things in a row? Everything to do with Databricks workflows. We're going to be talking in a similar style. Now, again, you can get your questions in advance. You can ping a load of stuff over, and I'll have a little list of questions to myself. Or join the live stream just like this. Ping the questions in the chat, and we'll see how we go and get through everything. There are a bunch of links that we've got from stuff we've looked at today. Now, obviously, that's just on screen, so that's not going to be too easy for you guys to get. We'll dump these links in the description on YouTube, in the description on LinkedIn. We'll make sure that's shared around. And we'll share some of those blogs that we've talked about in terms of making things easier, CI/CD, best practices, all of that good stuff. So you will have a ton of things to work through, to look at, questions to read, all of that stuff. So, yeah. That brings us to the end. So thanks everyone for joining. Thanks everyone in the chat. Really appreciate everyone giving your time and asking so many questions. And yeah, we'll catch you next time. Cheers.